This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET.
Hello friends, now we will discuss collision. So what is collision? Collision is an isolated event in which a strong force acts between two or more bodies for a short time, as a result of which the energy and momentum of interacting particle changes. So basically we will get three information in this statement. First information is that collision is an isolated event. So basically it is an internal process, or it's an internal event in which the forces or the interacting body imparts forces on each other. So there is no any role of external force in case of collision. So first thing is that it's an isolated event. Second thing is that in which a strong force act between two or more bodies. So if two or more bodies undergoing in collision, then a very strong force acts between these two bodies, and that force is usually for a short time. So basically a strong force acts for a very short duration, very short time, and as we know that a strong force for very short duration is called as impulse. And as a very strong force acts for a short time, then because of this force the energy and momentum of interacting particle changes. So we will see more about the collision. In the collision, particle may or may not come to real touch. So basically collision may occur with physical contact or without physical contact. We will first see the collision with physical contact, and collision with the physical contact is quite obvious in nature, like collision between two billiard ball or a bat or a ball. So if you see the collision between two billiard ball, then one ball is having velocity u while other is in rest. Now after collision, or in fact during collision, if you see that during collision the both particle imparts force on each other, and this is a strong force for a very short duration, and because of this force the energy and momentum of both particle m1 and m2 changes. So basically we may consider it an isolated event. So similarly, in case of collision between a bat and ball, these two particles interact for a very short duration, and because of this the energy and momentum changes. So this is the collision with physical contact. Now we will consider the collision without physical contact, and although such type of collision are not obvious in natural or in day-to-day life. So like head-on collision of alpha particle with gold nucleus. So what is this head-on collision? Head-on collision is basically the collision in which the both colliding particle are in the same line. So we will learn about head-on collision later on. First we will see that how alpha particle collides with gold nucleus, and basically it is from Rutherford scattering experiment in which the alpha particle, which is basically He2 plus, having two proton and two neutron. So in alpha particle we have two proton and two neutron. So basically proton is the charged particle, and so basically it has two proton or two unit of charge, and when it moves or it moves closer to the gold nucleus, then then it return back, or it retraces its path. Actually here some angle has been shown, although if it is purely head-on collision then there will not be any angle. Like the alpha particle goes to the gold nucleus, and suppose it reaches to a point which is the d distance from the nucleus. Afterwards it will retraces its path in backward direction. So basically if you see that it will not reach to the gold nucleus. why why this is possible, or how this is possible? This is possible because the alpha particle has some positive charge and the gold nucleus also has some positive charge, and because of this, as we know that the same charge repel, so because of this, it will have a maximum potential energy at a point this, at a point d distance from the gold nucleus, and from that point it will repel or it will return back. So we may say that it has the maximum potential energy at this point. Learn more about about collision, and the first topic in this is the different stages of collision. So in this figure, one force time graph is given, and we have plotted three stages of collision. First is before collision, second is the force during collision, and third is the force after collision. So if you see this figure, then before collision, this m1 and m2 mass are moving with a velocity u1 and u2, and we have a constant external force F external, which is very less. Now before collision, these two bodies are not in contact, so they are not exerting any force on each other. During collision, when these two bodies exert force on each other, then the force time graph changes, and if you see that during a short duration of time delta t, the force increases and reaches up to a maximum value. Afterwards, the force decreases at the time t2. So after time t2, these two body loses contact with each other, and it is depicted as a after collision. So if I show this figure, then before collision these two bodies are not in the contact of each other. If you see that at the time of collision or at just start of collision, these two bodies touches each other. Afterwards, during the collision, the deformation happened into these two body. These two body has some deformation happening, and these two are putting force to on each other, and this force will reach maximum point where we have a maximum deformation. So we may say that this is the case of maximum deformation. Here it's a maximum deformation, and correspondingly the maximum force is acting on both body. We may say that in this case the potential energy changes, because potential energy is associated with the configuration of body. So as the body is pressed from the other body, so we may say that the potential energy of system increases, and this potential energy increases on the expense of kinetic energy. So the kinetic energy of body decreases and the potential energy increases. After that, after the point of maximum deformation, the body started losing contact with each other, and some period of time they will just lose contact with each other and then moves with a different velocity independently. So these are the different stages of collision, and here if you see this figure, then this is the actual curve. That is, the force started increasing from the point t1 and stopped at the point t2. However, if you see, we have drawn a line which is called as force effective or the effective force, which is, if you take the ft, the area under force time, then this area will be equal to the area under actual ft graph. So basically from this figure, the area shown in this red curve will be equal to area by this. So from there we may clear that we have a very strong force work for a very short duration during collision. So all these things are written here. There are three distinct identifiable stages in collision, namely before, after and during. And in the before and after stage, interaction forces are zero, while during the collision between two bodies, interaction forces are very large, and it is unknown force. as the force is unknown, so we cannot obtain or we cannot apply Newton's second law to actually calculate the acceleration or the change in velocity. So what we will do, we will basically use the conservation of momentum to relate initial and final velocity, as this external force which is very small in comparison to the interaction force. If you see this figure, then the external force is very less, external force is very less in comparison to the actual force, and we may neglect this external force. As the external force is zero, so the conservation of momentum take place. As we know that from the Newton's second law, that dp by dt is equal to F external, and F external is equal to 0. So dp is equal to 0, and it means p is constant. Change in momentum is equal to 0, which implies that momentum is constant. So p is constant. So afterwards we just move to our next concept, that the energy and momentum conservation in case of collision. So first we will learn about momentum conservation in a collision, as the effect of external forces such as the force of gravity, force of friction are not taken into account, which we have already explained. So 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 due to which we just consider the net external force to be zero, and because of this the momentum will be conserved in case of collision. So this is a very important concept, that momentum will be conserved in case of collision. So in any type of collision we may consider momentum to be conserved. Second is that average impulsive force responsible for collision is much larger than the external force acting on the system, and since this impulsive force is internal, therefore the total momentum system is always remains constant. So what it says, that as we have seen that we have a large interaction force. However, this interaction force acts for a very small duration, and this interaction force we term as internal force, because in this interaction force one body is acting on this force on the other body, and the second body is in turn imposing this force to first body. So because this impulsive force is internal, so we may consider the total momentum of system always remains conserved. So what it signifies, how we signifies that total momentum remains conserved? So it means pi is equal to pf, that is initial momentum is equal to final momentum. As we know that the momentum is a vector quantity, so we will take the momentum along x axis, y axis and z axis, and we may correspondingly equate with the final momentum along x, y and z axis. So if I do this kind of calculation, then we get the initial momentum along x axis is equal to initial final momentum along along x axis. Similarly, the initial momentum along y axis is equal to final momentum along y axis, and the initial momentum along z axis will be equal to final momentum along z axis. So basically sometimes problems are also asked, that in which you have to write momentum in terms of vector form. On different cases of momentum calculation, that when the momentum of each ball is making an angle theta I with the horizontal axis, then how we'll calculate the momentum. So consider the figure given below, where the ball A is having mass m1 and ball B having mass m2 are moving such a way that it is making an angle theta in clockwise direction, while this second ball is making angle theta 2 in anti-clockwise direction, and is shown in this figure. So if you see this figure, then the momentum of ball A will be PA and momentum of ball B will be PB. So you can calculate the net momentum after dividing the individual momentum into x and y components. So the net momentum pi is equal to vector sum of momentum pa and pb. So if you see, that PA is making an angle theta 1 with the x-axis, so its component along x-axis will be PA cos theta, and the component along y-axis will be equal to minus PB sin theta minus PA sin theta 1. So if you see this figure, then it's a PA, so the component along we are considering this direction as a positive x and this direction as a positive y. Then the momentum will be PA cos theta I minus PA sin theta, in fact theta 1 j. Similarly, the momentum PB will be written as PB cos theta 2 I and plus PB sin theta 2 j. So we may write the net momentum is equal to PA cos theta 1 plus PB cos theta 2 I plus PB sin theta 2 minus PA sin theta 1 j. So in this way we can calculate the momentum of each ball in vector form. If we have to calculate the magnitude of momentum, then we will just take the magnitude of this momentum and it will be equal to the square of individual x and y components, and we just take a square root of it. So if I take a square root of it, then PA cos theta 1 plus PB cos theta 2 whole square plus, and then we will again do a square of this y component, then PB sin theta 2 minus PA sin theta 1, and we just take a square root of it. So in this way we can calculate the individual momentum. Now we consider the second case when the momentum of each ball is given, making an angle theta between them. Suppose the ball are coming in such a way, this mass m1 and m2 are moving in such a way that angle theta is given. The angle between the direction of their motion will be given and it is equal to theta, and we have to calculate the magnitude of momentum. So as we know that momentum is a vector quantity, so basically we have to add two vectors PA and PB, which is making an angle theta between them. So clearly we know that the addition of two vectors having angle theta between them is given by square root of PA square plus PB square plus twice PA PB cos theta. So in this way we can calculate the initial momentum, and we have to put it equal to final momentum in order to make the conservation of momentum. So basically you should note that in case of collision, any type of collision, the momentum will be conserved. Momentum will be conserved at any cost.